Okay, we're going to talk about a deadly proof. I am an applied mathematician, so there's going to be some things swept under the rug, but how do I go to the next screen? There we go. All right, everyone's familiar with Pythagoras' theorem. You had to deal with that when you were back in school. And what he basically said was, if I have a right triangle like this one on the right-hand side, and I square the lengths of the two shorter sides, then that's the same as the square of the length of the hypotenuse. And there's various clever ways you can restate that. In this particular example, if the two sides either side of my right angle are both of length 1, then what we would call the side length of the hypotenuse is the square root of 2, right? Everyone will good with this? Okay. So the square root of 2 is interesting because it's kind of an abstract representation of a number. It's defined in terms of the number 2 and the relationship of squaring. It's not directly representable. So the question we're going to address here is there a way to represent it in some more concrete way? If you've suffered through logarithms, kind of the same idea. Logarithms are defined in terms of exponentials rather than sort of explicitly and directly. So Pythagoreans, the group of people who followed the teachings of Pythagoras and thought he was awesome, they really loved whole numbers. But one thing that's sad about whole numbers is that we can't use those to represent the square root of 2. So if I square 1, then I get 1, and that's definitely less than 2. And if I square 2, I get 4, and that's definitely bigger than 2. So one thing I can say is that the square root of 2 has to lie in between these two numbers, but the whole numbers aren't going to cut it for our representation. But this is okay because the Pythagoreans are also really down with fractions and ratios. Like, they love those things, and they're like, yeah, we can put together our whole numbers in cool ways, and then we get fractions, and all is right with the world. So what we're about to do is, Sudoku fans, anyone? Okay, cool. So ideally, when you're doing Sudoku, you logically deduce the next step every time. But sometimes you reach a point in the puzzle where you can't logically deduce the next step. So what you do is you guess a number somewhere, and then you kind of you in pencil, and then you go with it. You go with it and keep going and make logical deductions with that assumption in place, and then see if you reach a contradiction anywhere. Right? And if you don't reach a contradiction, your original assumption was good, and you finish the puzzle. But if you end up with 2 6s in the same column, then you screwed up, and you have to go all the way back and undo your assumption and try again. So that's what we're going to do. We're going to make an assumption, and then make logical deductions based on that assumption and see where it takes us. So this is what I'm going to assume. I'm going to assume that I'm a Pythagorean, and I'm like, fractions are awesome. Surely everything's a fraction. So let's assume that the square root of 2 can be represented as a fraction. And I'm going to write it, square root of 2 is p divided by q. And the only other thing I have to say here is that we can choose our p and our q such that they don't share any factors. So this is basically just saying, if I have a number like 1.5, instead of writing it 18 over 12, I can always divide out factors down to something like 3 over 2, where those two numbers do not share any factors at all. So that might seem insignificant, but that's going to be important. So keep that in mind. No shared factors between p and q. So this is the place where we're starting with our assumption, and we're going to make like small algebraic steps from here. So if I square both sides, this is kind of the definition of the square root of 2. I say that, okay, 2 is now p squared divided by q squared. If I multiply both sides by q squared, and then look at the result, I can say, look, p squared is 2 times some number, so if I divide it by 2, I get some whole number result. So p squared must be even, and that means p is even. That's a little bit of sweeping under the rug, but it's true. If p squared is even, p is also even. So if p is even, that is also divisible by 2, so it's 2 times some number, which I'm going to call r. So now we're going to take one of the steps from the middle of the previous slide and this new deduction that we have, that p is twice some other number, and we're going to go ahead and stick that new representation of p into our equation. So now 2q squared must be 4r squared for whatever this whole number r was. If I divide by both sides by 2, I get back to an equation like q squared is 2r squared, which means that q squared is even, because if I divide it by 2, no remainder. And again, that means q is even, so q can also be written as 2 times some number s. Don't care what the number is, just care that it exists. So between those two slides, what we've said is, okay, p is twice of some number, and q is also twice of some number. But that's bad, because what it means is this ratio p over q that I started with is the same as 2r divided by 2s, which means that p over q reduces to r over s, and I explicitly stated at the very beginning That's not a thing that we can have happen because we can always just choose to start with the minimally reduced P and Q. So this is that part in the Sudoku puzzle where you've made your assumption at the beginning and you like fill out all the numbers and you're like, this is going great, and then you see like you've got two threes in the same box and you're like, shit, like this is where I know I've screwed up. And what you deduce from that is that your initial assumption is the thing that was bad. So that's what we've done here. This is called proof by contradiction. Assume the thing you want to be true and show that at least it's something that's logically ridiculous. So that's the conclusion. You can't represent the square root of 2 as a fraction. It's what we would call irrational. And I said at the beginning, this is a deadly proof. So the Pythagoreans, I said they were super into whole numbers, super into fractions. They were so, this is kind of a religious belief for them. They were absolutely convinced that these things were kind of pure and should be used to represent everything in the world. And when it turned out that was not the case, they got kind of angry and kind of stabby. And the guy who suggested that this would be the case, apparently they took him out to sea and drowned him there when he suggested that the square root of 2 was irrational, could not be represented by a fraction. That's it. Deadly proof.